This video covers discrete random variables, the binomial distribution, part 2. We're picking up with the slide titled Consider the following. A biased coin has a probability of 0.6 of coming up heads. The coin is flipped 3 times. Let x be the number of heads that come up. Create a probability distribution that lists the probabilities for all the possible outcomes of x. Alright, so x, p of x, what are all the possibilities? Well, we could flip a coin 3 times, and x is the number of heads that come up, so there's a possibility that no heads will come up. That's the first possibility. Or 1 could come up, or 2 heads, or 3 heads. Now what we have to do is find the probability of each. Alright, let's start with the probability that we flip a coin 3 times and we get no heads, 0 heads. So what does that look like? That would be getting a heads first. Scratch that. That would be getting no heads, so that'd be getting a tails with the first flip, a tails on the second flip, and a tails on the third flip. So to find that, we would find the probability that the first one is tails, the probability that the second one is tails, and the probability that the third one is tails, and multiply them together. Now, remember, the probability of heads was 0.6 because it's a weighted coin. So that means the probability of tails, so the probability of heads was 0.6. The probability of tails is 0.4. Alright, I wrote it a little bit neater right here so you can see it. So the probability of tails is 0.4. The probability of tails on the second flip is 0.4. And probability of tails on the third flip is also 0.4. If we multiply those 3 numbers together, 0.4 times 0.4 times 0.4, we get 0.064, so the probability of no heads is 0.064. So we'll go back to our probability distribution and we'll fill that in, 0.064. Now we need to find the probability that we get 1 head. So how could that happen? How can we get 1 head? So we could get, remember there are 3 flips, a heads, a tails, and a tails. Or we could get tails on the first flip, heads on the second, tails on the third. Or we could get tails on the first, tails on the second, and heads on the third. Okay, so stay with me. Keywords here are or for the first part. The second, we have multiple events happening in succession because we're flipping 3 coins. So let's break this down. When you have or, remember you're going to add the probabilities. So we're going to add the probability of heads, tails, tails with the probability of tails, heads, tails with the probability of tails, tails, heads. Alright, so let's keep going. So now to find each of these individual probabilities to add together, To find the probability of heads, tails, tails, you find the probability that the first is heads, the probability that the second one's a heads, and the probability that the third is tails, and multiply them together. See if I can write a little bit smaller. And then, for the second one, we find the probability that the first one's tails, the probability that the second one's heads, and the probability that the third one is tails. And then the third one, find the probability that the first one's tails, the probability that the second one's tails, and the third one's tails. And for each of these three, this one, and this one, we're going to multiply them together. And then we will add each of those. So, okay. You might notice everything's a different color all of a sudden. And that's because all of the ink disappeared a moment ago and I couldn't get it back. So I had to rewrite it. Okay, so going back here, the probability of heads is 0.6. The probability of tails, we'll just call that Q, is 0.4. So 0.6 times 0.4 times 0.4. And the probability of tails here is 0.4. Probability of heads is 0.6. And then 0.4. And then here the probability of tails is 0.4. Tails again is 0.4. And then heads is 0.6. And then again, after we multiply, we will add them. So when we multiply 0.6 times 0.4 times 0.4, we get 0.096. When I multiply 0.4 times 0.6 times 0.4, I get 0.096. And last, when we multiply 0.4 times 0.4 times 0.6, we also get 0.096. And if we add these three together, we get 0.288. 0.288. So we'll add this here, 0.288. Okay, now we want to know the probability of getting two heads. Exactly two heads. So what would that look like? Well, we could flip a coin 3 times and we could get a heads, and a tails, or a heads, a tails, and a heads, or a tails, heads, heads. And so just like before, we're now going to find the probability of a heads, heads, tails, and going to add it to the probability of a heads, tails, heads, and add that to the probability of a tails, heads, heads. So the first one, we find the probability of heads times the probability of heads times the probability of heads, and add that to the second one, which is the probability of heads times the probability of tails times the probability of heads, and add that to the third, which is the probability of tails times the probability of heads times the probability of heads. Alright, remember the P was 0.6 for heads, Q is 0.4 for tails. So 0.6 times 0.6 times 0.4 plus heads is 0.6, probability of tails is 0.4, probability of heads is 0.6, plus probability of tails is 0.4 times the probability of heads is 0.6 times the probability of heads is 0.6. And if we multiply 0.6 times 0.6 times 0.4, we get 0.144. If we multiply 0.6 times 0.4 times 0.6, we also get 0.144. And if we multiply 0.4 times 0.6 times 0.6, we again get 0.144. And when we add those together, we get 0.432. 0.432. So I'm going to put that in there. Okay, and last, we're going to do the probability of 3 heads. There's only one way to get that. That's getting a heads, a heads, and a heads. There's no other way to do that. So this one should be quick and easy. So to get that, we find the probability that we toss a coin in its heads and multiply that times the probability that we toss the second coin in its heads times the probability that the third coin is also heads, or the third toss. Remembering that probability of heads is 0.4. Excuse me, I'm sorry, that was 0.6 for probability of heads. So 0.6 times 0.6 times 0.6 comes out to be 0.216. And if we add all of these numbers here together that we just got, 0.064, 0.288, 0.432, and 0.216, they do add up to be 1. So that was a bit of a complicated process, and that was only tossing a coin 3 times with 3 trials. Imagine us trying to come up with the probability distribution for the hamburger scenario from Whataburger when we're bringing 10 people and we want to see if how many different people can win the hamburger. Well, we could, I'm sorry, it wasn't a hamburger, it was buying a hamburger and winning French fries. So they could be anywhere from 0 all the way up to 10. And for each one of those, there's all kind of countless scenarios of how that could happen. Like, let's say we brought 10 people and 3 won a hamburger. Well, which 3 won? Well, it could be first, second, and third, or first, third, and fourth, or first, fourth, and fifth. And you'd have to come up with all those combinations and find all those probabilities, so it would take a while. Alright, so why don't you pause the video and using this probability distribution that we just created on the previous page, it's the same one, answer these questions and then unpause to check. Okay, here are the answers. For exactly 2 heads, you just look at the table, 0.432, done. For no heads, that's the probability of 0. So again, just look at the table, 0.064. For less than 2 heads, that's the probability of 0 or 1. So which numbers are less than 2? 0 or 1. So when we have or, keyword or, we add the probabilities. So we're going to add the probability for 0 with the probability of 1. So 0.64 plus 0.288 is 0.352. For more than 1 head, more than 1 is 2 or 3. Again, keyword or, we're going to add the probability of 2 with the probability of 3. 0.432 plus 0.216 is 0.648. Probability of at least 1 is 1 or more. So 1, 2, or 3. So we're going to add the probability of 1 with the probability of 2 with the probability of 3. When we add those together, we get 0.936. And last, the probability of at most 2. At most 2 means no more than 2, so it's the probability of 0, 1, or 2. I'm going to add those together, I get 0.784. So we're going to end it here, and we'll pick up with the next slide in the next video.